neurons does not have any redundancies. Control mechanism. There is no control unit to the monitor the information processed to the network in biological neural network. Whereas in artificial neuron model, all activities are communicated monitored by a control unit. Okay, so on that there is no control unit in biological neural network, but whereas artificial neural network has a control unit. It's monitored through control unit. But in case of biological neural network, they does not have any control unit. The next important one is here the important points you should remember: human brain versus artificial neural network. The important points is speed, comparisons are processing, processing, size and complexity, size and complexity, stored processing, tolerance, control mechanism. These points I already explained just now in a depth. Control mechanism. These are the important things. Next important one is characteristics of artificial neural network. Characteristics of artificial neural network. Let us be discussed at the last. First point is it is mathematical model consists of computation elements implemented neural. The second point is large number of highly interconnected processing elements known as neurons are prominent in artificial neural network. The third point is interconnections with their weights are associated with neurons. Fourth point, the input signals arrive at processing elements through connections and weights. Artificial neural network collective behavior is characterized by their ability to learn and recall and generalize it from the given data. So a single neuron carries no specific information. Here, these are the characteristics of artificial neural networks. Okay, this is a mathematical model, of course. Okay, computational elements are implemented. The characteristics is one of the most point is it's a mathematical model. It's a mathematical model, no doubt on that. Okay, it's mathematical neural network is a mathematical model. Large number of highly interconnected processing systems known as neurons are prominent in artificial neural network. Okay, highly interconnected processing elements and neurons interconnected processing. Highly interconnected processing units. That means neurons, set of neurons. Okay, that is neurons prominent in artificial neural network. Okay, so the interconnection with their weights are associated with the neurons. Interconnection of weights. This discussion is depends on weights. Weights associated with neurons. Weights associated with neurons. Weights associated with neurons. The input signals arrive at the processing elements through connections and weights. input signal, how the input signal will arrive through connections and weights. How the input signal will arrive through connections and nodes. Artificial neural network collective behavior is characterized by the ability to learn, and recall, and generalize from given data. It's a collective behavior. ANN's collective behavior is characterized by the learner, recall, and generalize of given data. Next point is ANN's artificial intelligence is collective behavior. Okay, artificial neural networks collective behavior. In short, it is called ANN. Okay, a simple neuron carries no specific information. Once a simple neuron, this is very one of the important characteristics. A simple neuron carries no specific information. Simple neuron carries no information. A simple neuron carries no information. Next one is architecture of simple artificial neural net. Simple neural network, artificial network. Architecture of simple neural network. Just examines architecture. X1, small x1, x1 inputs, capital X1, x2 are in the blocks, W1, W2 weights. Okay, why what we discussed at this point is like that only. Okay, some weights. Okay, what we discussed. Okay, the interconnection with their weights and associated with neurons. Interconnection with their weights associated with neurons. The interconnection with their weights are associated with neurons. Neurons the weights associated with interconnection of weights associated with the neurons. From the given figure, there are two input signals, transmitting signals for the output neuron Y for receiving signal, and the input neurons are connected to the output neurons. Okay, over a weighted interconnections links. That what I said characteristics point and the characteristics law what we discussed this point only. That's what that is the I'm highlight that point only. I'm based on that concept only. I'm developing the architecture. Weighted interconnection links W1 and W2 are the weighted interconnection links. You can easily understand this diagram. Just observe my characteristic point and diagram. Okay, so then you can understand I'm implementing my concept to the with the help of diagram. Okay, just see the diagram actually. Okay, in the figure above there are two inputs neurons transmitting signal to the output neuron Y for receiving signal. The input neurons are connected to the output neurons over a weighted interconnection links weights W1. Let's see the characteristic point. This is the heart of this neural network architecture. The interconnection with their weights and associated with neurons. This is the and associated with the neurons. That's why represented in the simple architecture of the neurons. Okay, from the input can be carried, inputs has to be calculated. So corresponding weights x1 w1 just multiply these two x2 w2 plus x2 w2 where x1 and 2 are activation of the input neurons of x1 and x2. The output of the output y can be obtained by applying activation over the net input y is equal to y of y by n. output function, not input included. The function to be applied over the net input is called activation function. Basic models of artificial neural networks. The models of adapted for updating and adjusting the connection weights. The third one is activation functions. Activation functions. Basic models of artificial neural network. You have to tell the explanation. I'm listing those basic models. You have to write explanation for this also for each and every concept. The first is models synaptic interconnections. Model synaptic interconnections. The learning rules adapted for obtaining existing the connection weights. Learning, learning the rules adapted for obtaining existing connection weights. Learning rules updating and adjusting the interconnection weights. The third last one in the basic models is activation function. Activation function. That's the third point. You should explain the 3 points clearly. That's enough. And the explanation of basic models of artificial neural networks. The point is the model synaptic interconnection. Artificial neural networks consists of a set of highly interconnected neurons connected through weights in the other processing elements are itself. The arrangements of these processing elements and the geometry of their interconnections are important for artificial neural network. The arrangements of neurons to form layers and the connection patterns formed within and between layers called artificial is called the network architecture. There are five neuron connection architecture. Single layer feed forward network. The second one is multi-layer feed forward network. The third one is single node with its own feedback. The fourth one is single layer recurrent feedback. The fifth one is multi-layer recurrent network. Single layer fed forward network. It consists of single layer of network where the inputs are directly connected to the output, one per node with a series of various weights. Okay, just see the diagram how they are connected: input layer, output layer, input neurons, and the output neurons. They are connected seriously. The multi-layer feed forward network, it consists of so multi-layers within along with the input and output layers. They are so they are hidden layers. There can be zero to many hidden layers. The hidden layers is usually internal to the network and has no direct contact with the environment. Okay, the network has no direct contact with the environment. Just there, see that difference between serial and parallel. Okay, this you can observe in this diagram. Okay, input connections and output connections, how the weights. Okay, already that characteristic point what we discussed corresponding weights and nodes, okay, inputs, okay. The you can observe that in the multi-layer single node with one feedback. This diagram you have to learn the diagram, that's enough, okay, to get a good marks, okay. So it's theoretically simple, but you have to practice the diagrams. The simplest neural network architecture giving feedback to itself with a single neuron input feedback, single neuron, single layer recurrent network, single layer network with a feedback directed back to itself, to the or to other processing elements or both. This is about single layer network. The next one, multi-layer recurrent network. A recurrent network has at least a feedback in place processing elements. Output can be directed back to the previous layer. Okay, this is according to multi-layer networks. Output, what happened here? It is a recurrent network. The processing elements output can be directed back to the nodes to the previous layer. Okay, it's a feedback network, of course. Okay, learning. The most important part of artificial neural network is it capability to train or learn. It's basically a process by means of which a neural net adapts for existing or updating the connection weights in order to receive the desired response. Learning artificial neural network is broadly classified into three categories: supervised learning, so unsupervised learning, reinforcement learning. This is most important point, conceptual, technical oriented point. Supervised learning. In supervised learning, it is assumed to that the correct target output values are all known as for each input pattern. It is the learning a supervisor or teacher is need to for error minimization. So the difference between the actual and desired output vector is minimized using the error signal by adjusting the weights until the actual output matches to the desired output. Okay, unsupervised learning. In unsupervised learning, the learning is performed without the help. There are different techniques. Supervised learning means it is output values are known for each input pattern. Output values are known for each input pattern is nothing but supervised learning. Output values are known for each input pattern. But in unsupervised learning, the learning is performed without help of a teacher or supervisor. In the beginning process, the input is the vectors are similar to in unsupervised learning. The learning is performed without the help of teacher or a supervisor. In the learning process, the input vectors of similar type grouped together to form clusters. The desired output is not given to the network. The system learns on its own with the input patterns. Okay, so without the help of the supervisor, okay, you can get the so unsupervised learning. Reinforcement learning. Reinforcement learning is a form of supervised learning, and the network receives the feedback from the environment. Here, the supervisor does not present the desired output, but learns to the critic information. Okay, just see the definition of supervised learning. It's important for the examination point of view. Let's see supervised learning. This is regarding to supervised learning. Okay, I already highlighted about the supervised learning. Okay, Correct target output values are known for each input pattern. Correct output targets for a known each input. But in unsupervised learning, there is no presence of supervisor. Okay, and learning process. This is unsupervised learning. Okay. Reinforcement learning. Reinforcement learning is a form of supervised learning as the network receives the feedback from its environment. Here, the supervisor does not present the desired output but learns the critic information. It uses the critic information. Okay, this is about reinforcement learning, supervised learning, unsupervised learning. Supervised learning and unsupervised learning and reinforcement learning. The activation function. An activation function F is applied over the net input to calculate the function. The choice activation function to be solved by the identity function. It is a linear function. It is defined for all x. Binary function is defined as f of x is equal to x less than equal to 0. 0 if x less than 0. Most common functions. Identity function is a linear function. It is defined f of x is equal to x for all x. Binary step function. The function can be defined as f of x is equal to 1 and x greater than equal to 0. 0 is greater than 0. Here, theta represents the value. Bipolar step function. The function can be defined as f of x is equal to 1, x is equal to minus 1, x less than 0. Here, theta represents the threshold value. Signification. To me, use proportions. There are two types. Binary step function is a simple function. Is by here lambda is the step parameter. The range of size sigmoidal function is from 0 to 1. So bipolar function is the function as of x is equal to 1 e power minus jx by 1 plus e power minus jx. Here lambda is the stepness parameter. The range of sigmoid function is from -1 to +1. The ramp function is defined as x is equal to 1, x greater than 1, x less than 0 less than equal to x less than equal to 1, 0 x less than 0. The graphical representation is shown in activation function. Technologies of artificial neural network is the first points weights. Okay. In artificial neural network, every neuron is connected to other neuron. Okay. Terminologies of artificial neural network. The first point is weights. Weight is a parameter which contains the information about input signal. This information is used by the next to solve a problem. In artificial neural network architecture, every neuron is connected to other neurons by means of a directed communication link, and every link associated with weights. WN is the weight from the processing element. I, source to node to processing channel. J, destination node. Bias. The bias is a content value introduced in the network. Its impact is seen in calculating the net input. The basis is included by adding components x not equal to 1 to the input vector capital X. Bias can be positive or negative. The positive has helps to in increasing the net input of the network. The negative bias helps in decreasing the net input of the network. Threshold theta. Threshold is a set of value used in activation network. If activation neural network based on the threshold where the activation functions are defined and output is calculated. So learning rate. So the learning rate is used to control the amount of weight adjustment by each step of training. The learning rate changes from 0 to 1. It determines the rate of learning of each time of the step. Okay. Next one is neuron, one of the neuron model. Okay, so microchip it's that is called empty neuron model. In this neuron model was the earliest neural network model discovered by the some expert at 1943. So the empty neurons are connected by directed to weighted paths. So the activation function of this the activation function model is a binary. The weights associated with the communication links may be excitatory. Weight is positive, inhibitory when weight is negative. So each whether weight is positive or weight is negative, that is most important. Okay. So each neuron has a fixed threshold, and the input to the neurons is greater than the threshold. Then the neuron from the otherwise it will be not fired. Concept of linear separability. Concept sets of print in 2D space and linearly separable. The point can be separated by straight line. So artificial neural network linear separability. The concept where the separation is based on the network response being positive or negative. Okay, a decision line drawn to the